I'm one of the instructors here at Southern Crescent Technical College, and we have developed a technical certificate course in small unmanned aircraft systems. And I want to really briefly run through the program just to give you an idea of what's involved. It's basically 16-week terms, a normal semester. We start out, it's building block concept, of course. We start out with AVOT 2001, which is basically UAV concepts. So we touch on a lot of different factors, aerodynamics, especially related to drones. We touch on the regulations, aviation weather. It's divided into lecture classes, and then every week there's be a lecture class and then a lab class in which we'll actually fly. We'll start out with a simulator for a few lessons just to get the feeling of how the controls work, and then we have this drone facility here where we have some smaller drones that we'll be able to fly and get proficient in basic flying. And depending on how quickly we progress, we might be able to move and do some outdoor work. It all depends on a number of factors, but this should be a fairly easy course, if I can put it that way. It should be enjoyable, touching on many concepts and also doing some flying. Then we move into the next part of it. That's 16 weeks. If we can do both these courses at the same time, for example, this one perhaps Monday and Wednesday, and then the AVOT 2010 flight development, do that on alternate days. Flight will be 16 weeks also. It's developing precision, precise flying, smooth flying. It takes some time. We'll have obstacle courses, and we have all of our drones have really good cameras, so we'll mostly be emphasizing taking accurate images according to different software requirements. So that's basically that. So developing some really good flight habits. And of course, we'll keep mixing aerodynamics and regulation, all of the other things that we've built on here. We continue to build it in flight. Okay, so that's one term. 16 weeks here, 16 weeks there. If we can do them both at the same time, it can be done in one term. I understand the student may be doing a lot of other things in their life, and may not have time for that, but that's the plan, if we can do that. Then we move into the next semester, the next term, and we'll start with AVOT 2005, which is commercial applications. And that's the stage where we take information, take the data that we've collected in the field, and enter it into our computers, into our software systems. We have map-making software, so we take images of a plot of land, and then we convert it into a map. Some of them are three-dimensional maps, some of them aren't. Some of them are agricultural maps that are determining the health of the plants. We will have the capability of taking thermal imaging as well, and that will be very useful for, well, there's just so many applications, but thermal imaging will be helpful, obviously, for search and rescue, but for other applications, like a factory would want to know where their energy is going, where their cooling system, where that cold air is coming out of the roof of the building, perhaps. Or even residential sections would want to know that kind of thing. So that's what this is all about, is taking data and turning it into useful applications. And after that, we'll take, this is a divided one semester. We can do two things. One of them is 2003, which is aviation weather and national airspace system. We need to really get good at that and have good skills in that. And then AVOT 2103 is the regulations. The Federal Aviation Administration, the government has many regulations that involve drones, and we need to know them. After we do these two, we can take the FAA knowledge exam to earn the small unmanned aircraft systems rating. So we have the actual certificate. Completing all of this earns us that technical certificate. So we can go to an employer and say, I've got a logbook full of time where I've flown, the Tello drone, the Mavic Minis, the Phantom Pro X, the Parrot thermal imaging, and perhaps by that time we'll have a fixed wing drone. I've got all this experience in different kinds of airplane types, plus I have the knowledge of commercial applications that perhaps might be helpful to you but I've proven my ability to learn new software systems. Obviously I have the license and have the information where I can actually legally fly in the airspace, which is important. So we can go there with something. It's not difficult to go to the big box store and buy a drone and learn how to fly it. That's perhaps not, but to fly it precisely and accurately and smoothly, that's another thing. That takes time, it takes expertise. Plus the fact, buying a drone on the street and flying it doesn't give you the ability to convert the information you gain into useful applications. And of course, knowing the rules, pretty important. So that's the basic thing. 2 terms, so 1 term, 2 terms, each 16 weeks. That's again, if you can take, Tuesday, Thursday, these 2, Monday, Wednesday later in the semester, right? Does that make sense? So I just want to give you a rough outlook of sort of how this course goes. These 2 can be flopped, or you can do the concepts and commercial applications, and then put this up here. These 2 can be flopped, but this needs to be at the end, this needs to be at the beginning. These 2, by the way, do follow each other. This is a prerequisite of this one, so this must be done first before the aviation weather and national airspace system must be learned before we go to the regulations. Other than that, we can have a good time with this course.